So in this video, we're going to be introducing the idea of the trigonometric functions. Suppose that we have an angle that is in standard position. We're going to make it a quadrant 1 angle, like so. And we'll use the angle denomination theta for that one. So first thing we're going to introduce is the concept of a reference triangle. A reference triangle is when you take an angle in standard position, take any point on that angle in standard position and connect it vertically down to the x-axis. So connect an angle in standard position vertically to the x-axis. A reference triangle is automatically a right triangle due to the fact that the vertical side and the horizontal x-axis are always guaranteed to be perpendicular to each other. Additionally, I would like to label the three sides associated with this reference triangle. The three sides are going to be referred to as A, B, and R. A is going to be the horizontal side. B is going to be the vertical side, and R is going to refer to the hypotenuse. Now, I imagine when it comes to right triangles, you're probably used to a slightly different nomenclature associated with this, so I'm going to recopy this down in another fashion. So we'll call that A and B and R, with our theta being right here. There are also other denominations that we use to label these three sides, and those three denominations are referred to as A, O, and H, where A stands for the adjacent side. Adjacent means directly next to, so adjacent to the angle would be the adjacent leg. O is referring to the opposite leg, and H is, of course, referring to the hypotenuse. Now you'll notice when I made reference to the reference triangle, sorry. I didn't mention what point on the terminal side of the angle we're supposed to use to connect down. So I could have done so out here and created a slightly bigger right triangle, or done so right back here and created a much smaller right triangle. The important thing is all of these reference triangles that I'm creating, they're all similar to each other because they definitely have theta in common, and they're definitely all going to have a right angle in common. Then using angle-angle similarity for triangles, that means that they're all similar to each other. In a theorem from Euclid, the father of Euclidean geometry, Euclid's theorem states that when you have similar figures, so in similar figures, ratios of corresponding sides are equal. So in similar figures, ratios of corresponding sides are equal. So what that means for us is when we create a right triangle of all of the different reference triangles that we can create, then ratios of the corresponding sides will always be equal. For example, the ratio of the B over A will be equal for all of these reference triangles, or the ratio of R over A, or R over B. There are really 6 different ways that we can set up ratios of those sides. So what I'm going to do is refer to the figures that I mentioned just a moment ago. SP is going to stand for an angle that's in standard position, and the labels for the sides that I'm using for this are going to be, once again, A, B, and R. I'm also going to use RT for right triangle. Right triangle, I'm going to refer to these three sides as the adjacent leg, the opposite leg, and the hypotenuse. So, with those things in mind, and please feel free to refer back to this point in the video, I am going to introduce a total of 6 different ratios that are used. I'm going to introduce them by name, by notation the ratio according to standard position and the ratio according to right triangles. There are 6 of them. First one is referred to as the sine of an angle. Now, for all of these trigonometric relationships, they do serve as functions, which means that it'll be necessary for them to be given an input. The input that we're referring to is the angle name from the previous page. So, unless otherwise indicated, we're simply going to grab the first 3 letters of the trigonometric ratio and make that our notation. The ratio for standard position would be b over r. For the right triangle, that is the opposite leg over the hypotenuse. Every time we introduce a trigonometric function, the next thing we introduce is going to be the same ratio but with a co in front of it. So after sine, we have cosine. The notation, we take the first 3 letters, and that'll be the notation, so cosine of theta. This ratio from standard position is going to be a over r, or from a right triangle, this would be the adjacent leg over the hypotenuse. Third one we're going to introduce is referred to as the tangent of an angle. Notation stays consistent. This will be tan of theta, or tangent of theta. This ratio, according to standard position, will be b divided by a, or from the right triangle, that'll be opposite over adjacent leg. We introduced a new trig function, so the next one we introduce after that will be the same thing, but with a co in front of it. Notation stays the same. This will be COT to refer to the cotangent. This ratio is going to be a over b, or the adjacent leg divided by the opposite leg. Last 2. Next one is called the secant of the angle. I like to say this one's the University of Alabama's favorite trigonometric function because it's SEC. If you didn't get that, ask a football fan. So SEC of theta, the secant of theta, that'll be the ratio of r over a, or the hypotenuse over the adjacent. I made a joke about the University of Alabama, so it made me say, ha! Finally, the cosecant of theta. Now, unfortunately, we can't use the same mechanism for this because we've already used COS, so we're going to go with the fact that cosecant has 3 syllables and just use the first letter of each syllable. Cosecant. So CSC of theta. Cosecant of theta is the ratio of the hypotenuse to the adjacent leg, so I want you to keep in mind cosecant's a hoe. Oh yeah, I regret nothing. Cosecant's a hoe. Eventually, all 6 of these ratios are going to need to be memorized. I will let you know that there is a clever way for remembering the first 3. I refer to the first 3 as the big 3. No disrespect to LeBron James from back in the day, but this is the real big 3. The mnemonic device that we use for this is by saying that the sine of an angle, sine, as for sine, is the opposite over the hypotenuse. Opposite over hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. Spells out a 9-letter word that has a relatively easy pronunciation, SOHCAHTOA. SOHCAHTOA. Say it once with me. SOHCAHTOA. All right, I really hope that you guys did it, because otherwise I feel kind of silly. There are other mnemonic devices that I've heard. For example, some old hippie caught another hippie tripping on acid. A little insensitive to the hippie type, so what I really prefer is sex on hard concrete always hurts the other's ass. Perfect. Love it. Now, if you can remember the big 3, the next question is remembering the others. Now, with that in mind, you'll notice that some of these ratios happen to be reciprocals of each other. The tangent and the cotangent happen to be reciprocals of each other. The cosine and the secant both involve the adjacent and the hypotenuse, and the sine and the cosecant also happen to be reciprocals of each other. Now, this one's kind of difficult to do on a video, but I'm going to try it anyway. if you take these three trigonometric ratios and flip their top and bottom, yeah, I don't have the room in here to do so, but basically the top one becomes the bottom one, the middle one becomes the middle one, and the 2 becomes the 5. That's how you can remember which one goes with what. So, as an example of identifying all of these things, actually, you know what? We'll do that in a separate video.